Okay, just recap from the previous lecture. We learned about series. Okay, in series RLC. So series RLC, we can see that the resistor, inductor, and capacitor RLC, and also voltage source is in series. Okay, series connection. Series connection, resistor, inductor, and capacitor is in series. R, XL, JXC. So we have the total, the combination of R, L, and C we call impedance, Z, equal to R plus J XL minus XC. Okay, this one we call impedance. Impedance. Okay, unit is ohm. Ohm. Okay, OHM. Ohms. Okay, impedance and unit is ohm. Connection is in series. Series connection. R, L, and C is in series connection. Okay, now for parallel connection, so the R, L, and C is in parallel. Okay, this one. We have R, resistor, inductor, and capacitor in parallel. R, L, and C, parallel. Okay, so this one is become XL, this one is become XC. Okay, we know that you already learned about parallel connection of resistor. Okay, this one is, let's see, we have resistor here, resistor, resistor, R1, R2, and R3. So this is R total. Okay, R total is equal to parallel, sorry. R total equal to 1 over RT equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, this one is to find total resistance for parallel connection. For series, we just add all resistor. However, for parallel, you have to 1 over R1 plus 1 over R2 and plus 1 over R3. Okay, same goes to the RLC parallel circuit. So impedance, Z is impedance, Z. So 1 over Z equal to 1 over R plus 1 over XL plus 1 over XC. Okay. Okay, for impedance, we also can write as admittance. So that is Z is impedance. 1 over Z is equal to Y is admittance. Admittance. So admittance is inverse of the impedance. Y is equal to 1 over Z. Z equal to 1 over Y. Okay? Y is admittance. For the unit is, okay, for impedance is ohms. Ohms, impedance is ohm. Where is it? Okay. Impedance is ohm. For admittance is inverse of the impedance. So unit is symbol like this. Unit is MHO. Okay, mho. Okay, inverse of the ohms. Or sometimes we can write as S. S for Siemens. Okay, that is unit for admittance. Okay. So far, any question? So just we can write as a Y here. Y go to 1 over R plus 1 over SL. Okay, equal to 1 over R plus, okay, we know that XL is equal to J omega L, XC equal to 1 over J omega C. Someone want to join? I thought. Okay. Okay. Okay, XL. Okay, 1 over XL, which is equal to 1 over J omega L plus 1 over J omega C. So we can write this one as 1 over J omega C. Oh, sorry. Oh, why? Okay. One over J omega C. So J omega C. Okay. Now we can bring J to the up. So to bring it 1 over R plus minus J over omega L plus J omega C. Okay, now we can combine both J, it will become 1 over R plus J omega C minus 1 over omega L. Okay, this is we call admittance. Why? Admittance. Admittance. Okay, admittance. So for J part, we can combine this part. Now we can take this one as G and this one as B. So we can simplify as Y equal to G plus JB. Okay. Where B where G is 1 over R and B equal to omega C minus omega L. Oh, this one, huh? This one is B. This one is G. G for conduct. So opposite of the resistance. Resistance is R. G is 1 over R. R is resistance. So resistance will block the current flow. Block the current flow. And G is 1 over R. So inverse of the resistance will become conductance. It allow current flow. Okay. So any question for this part? For the admittance parts, so admittance is 1 over R plus this one. This one. Take this one. This is simplify already. Simplify and become this one. So any question on the admittance part? Admittance is inverse of the impedance. Sorry, admittance impedance. Okay, inverse of the impedance. Impedance is Z. So admittance is 1 over Z. Unit is mho. For impedance, Z unit is ohm. Okay. All right. So next. Okay, again we have J part. So now we have Y equal to 1 over R plus J omega C minus 1 over omega L. Okay, we have a complex number J complex number. Let's say this one is, for example, we just A, B, and C. So A equal to B plus JC. When we plot, we have graph, complex number. This one real. This one is imaginary. Imaginary part, real part. So imaginary part is belongs to C. Real part is B. This one is B. Okay, imaginary is C. You have C. C. Okay, now we have A, B, and C. So we know that this one is in complex number. We can write in polar form this complex number. So if for polar form, we can write as A magnitude and angle theta phi. Okay, where A is sorry, B and B. B is in real part, so this one is B. C is in imaginary part, C, imaginary J. C. This one is A. A equal to B plus JC. A is equal to B magnitude B plus magnitude C. Okay, this is phi. Okay, this is you already learned in your trigonometry where A square plus equal to B square plus C square, and A equal to B square plus C square square root. This is the magnitude. Okay. So when we apply this theorem into here, we get is Y magnitude equal to 1 over R square plus omega C minus 1 over omega L square root. Okay. This is the magnitude of Y. Magnitude of admittance. So now we have magnitude and angle. How to find the angle? Okay, angle here. You already learned in your trigonometry. Theta phi equal to tangent C over B. Yeah, tangent C over B. Opposite over side. Okay. So phi will be equal to tangent inverse C over B. So this one is tangent here. Tangent theta, tangent phi. Tangent phi equal to C over B. So phi equal to inverse tangent A over, not A, C, C. This part, C over B. Okay, then phi will be equal to tangent C is equal to, this part is C omega C minus 1 over omega L divided by 1 over R. Okay, this one is the formula for magnitude of the admittance and magnitude of, magnitude and angle of the admittance. So any question? I think I'll just explain in one page. Okay, for this one. Okay, magnitude of admittance and angle of admittance. Okay, any question, just ask me. I can explain again. No question. Oh, very good. So now let's say we have our circuit R, L, and C. Our voltage here. So we have current here, I. So how to find the current? This is sine wave. So we have two methods to find the current. First method is we find current here, let's say I1, I2, and I3. Then I equal to I1 plus I2 plus I3. Okay, this is Kirchhoff current law. Kirchhoff current law say that the total current enter a node. Let's say this is a node. This is a node. So one node, same node. They have 3 branch, 1, 2, 3, 4 branch. So they at the node. So current enter the node. Total current enter. Okay, KCL said total current enter the node is equal to total current leaving. So total current enter is I. This one is I. Just one current enter the node. So I1, I is I. This is current enter. I enter. This is I leaving. Okay. So total current enter the node is equal to total current leaving the node. Okay, summation. We sum I1 plus. So we have, in this case, we have just one current enter that node, which is I, capital I. Only this I enter the node. So I enter is equal to I. And we have 3 I leaving the node. I leave node, I out of the node is 3. We have I1 plus I2 plus I3. So that's why I equal to I1 plus I2 plus I3. This is KCL, Kirchhoff current law. Okay. So how to find I1? We know that for parallel connection, for parallel component, the voltage here, this voltage, so they have same voltage, is equal to this voltage, this voltage, this voltage. So voltage across R equal to V, this V, equal to voltage across L and equal to voltage across capacitor. So they have same voltage for all three components due to parallel connection. So what we can find is we just I equal to V divided by R plus V divided by XL plus V divided by XC. Okay, this is how to find the current, this current. So this is first method. The second method is we can use admittance. Okay, we can use this one, admittance. Okay, we can use this one. We sum all the resistor, inductor, and capacitor. This is voltage. This one we can combine, become like this. Just one. Okay. Okay, we can become Y. Y. Where Y equal to this one. Okay. Okay, become Y, and then this one is voltage. This one is current. So how to find Y? How to find current? Using Ohm's law. Ohm's law, where V equal to IR or IZ for impedance IZ. So in this case, we have Y. We know that Y equal to 1 over Z. So V will be equal to I over Z, sorry, I over Y. Okay. Ohm's law say that V equal to IZ. So we know that Z equal to 1 over Y. So means that V will be equal to I over Y and I equal to V Y. Okay, Vy. V times Y. Okay, Y is equal to, where is Y? Okay, this one. Y equal to this formula. So we just using that formula. Okay, I equal to Vy equal to V times Y. Okay, this one is V. This one is Y. Okay, an angle, just take tangent. This one is angle. This formula. This one, angle. Okay. Okay, here. This is for I, that is for angle. That's I. I is equal to V times Y. V times Y. And this, okay, this one we call magnitude of supply current. I magnitude. This one is first angle of the emitter. Okay. So any question? How to find current and how to find phase angle? Is it okay? Okay, good. Okay, now, what is it? So this one I already explained. Okay, V branch current. Okay, in this case we have IR V here, branch current IR, IC, and IL and IC. So current for each branch. Current pass through R, we can say IR. Current pass through L, we can say IL, and current pass through C and IC. So this one is I total. Okay, IL is equal to voltage across L divided by XL. Okay, voltage across L is equal to V. We already explained before. Across C and across R. Okay. In parallel connection means that the voltage, this voltage equal to the voltage V. Okay, voltage across C equal to voltage across L equal to voltage across R equal to supply voltage due to parallel connection. Okay. Okay, current through resistor, current pass. Okay. Okay, IR equal to V over R. For IL equal to V over XL equal to V over J omega L equal to, so we can bring J to the up, so minus J V over omega L. Okay, minus J. This one is for IC equal to V over XC equal to V over 1 over omega C equal to, sorry, this one is J. J 1 over J omega C equal to J omega C times V. Okay, when we look at these three equations, okay, we can say this one is, they have, for IL and IC, they have J. J means that imaginary axis. For IR, there's no J. Means that it's on the real axis. So we have imaginary axis and real axis. Real axis, imaginary. J for imaginary. So for IL, there is negative. So it means that negative is here, IL. For omega, for IC, positive value. So on the top one, this is IC. For IR, there is in real IR. Okay. Any question to plot this one? I can repeat again if you have question on this plotting of the real and imaginary axis. For imaginary, J number. For real, there is no J number. So we have capacitor. So at I capacitor is on the top, and I for current for inductor is on the bottom part, on negative part. Okay. Okay, leading and lagging. So now I'm going to explain to you about leading and lagging. So we have, I believe you already learned in your secondary school about the angle. Angle, let's say this is our angle. This is our, okay, angle, how to read angle? Let's say we have this angle. How to read angle? Angle is, okay, this one is 0. Angle is from this 0 to read angle is like this direction. Angle. Like this. Okay, angle. From here, okay, this angle, theta, let's say theta. Let's say we have angle, okay. Let's say we have angle here. Okay, how to read this angle? Where is angle? Angle is from 0 as this angle. For this one, angle is from here to here. Angle. For this one, it's angle from here to here. Okay, for this one, angle is from here to here. Okay, this angle. Okay, from here. So counterclockwise. Okay, counterclockwise. To read angle is counterclockwise. Okay. For example, this one. Okay, in our case, we have okay, RL. Okay, look here, RL is bottom. This one is V. Our voltage. Our voltage is at rail axis, and RL is RL here at the bottom. Imaginary axis. J, this one. Okay. So this one is RL. This one is V. So let's say we rotate it counterclockwise. We rotate counterclockwise. We rotate this one counterclockwise. This one is in front of the V, in front of the IL. Okay, V in front. V at the in front of IL. When you rotate it, we rotate it. Just rotate it. So it will come together. So when you rotate like this, so you rotate, for example, so rotate. So V is in front of the IL. IL is behind V. Okay, there are two terms. We can say that V in front of IL or IL behind V. In terms of electrical, we can say that V lead, V leading. IL with 90 degree. Or we can say that RL lagging, lagging, V with 90 degree. Okay, is it okay? Leading and lagging. So when we rotate this counterclockwise, V will in front of IL. IL is behind V. You just imagine it rotate here, rotate like this. So when V is here, IL will be here. We rotate again. Rotate again. V here. IL will be here. Rotate. So V will IL here. So we can see that V always leading IL with 90 degree. Or we can say that IL is lagging V 90 degree. Is it okay? For this one, lagging. So IL current IL lagging, lag voltage by 90 degree. Always due to J, negative J. This negative J. This one, negative J. Okay, now we when we refer to IC, now is IC. So this V maintained at the real axis. IC is here. IC. Okay, IC. IC is at this axis. The positive J, positive imaginary. Okay. IC positive, this IC. So positive imaginary. So on the imaginary positive, real positive. Okay, this is 90 degree. So again, we rotate counterclockwise. Okay, we rotate counterclockwise. We can see that IC is leading voltage by 90 degree. Okay, rotate it. You just rotate it. And rotate it. IC here. V will be here. So 90 degree. Rotate again. V here. IC here. V will be here. Okay, means that IC leading, or sometimes we can say that voltage lagging IC with 90 degree. Okay, current in capacitor leading voltage by 90 degree. Okay. Okay, this one. Okay, again, IL. So sorry, where is it? Okay, IR, IL, IC. IL, IC, I total. So I equal to IR plus IL plus IC. We know that IL is equal to IR plus J. IL is negative, huh? So IL negative, IL is minus J. IC is positive. So IC minus IL. Okay, IR is equal to JIC minus IL, I equal to I total. So from this equation, we can say that the magnitude of I will equal to, again, we use trigonometry, IR square plus IC minus IL square root. Okay, this one is magnitude, and angle equal to tangent IC minus IL over IR. Okay, this is angle of the current. Magnitude of the current is I square, IL square plus IC minus IL square, square root. Okay. So any question on this topic, on this part? Any question on this part? Okay, good. So, tak ada question ni. Clear kan ni? Ke tak ada orang kat sini? Pelik juga tak ada question. Okay, in this case of the phase angle, so we have case 1, case 2, and case 3. For case 1, RL is greater than IC. Okay, we know that RL is at the bottom, IC is, so RL is here, IC is here. So for example, if RL, let's say RL is greater, RL is greater, so means that there will be bottom will be greater. For example, RL is 100, IC is just 10. This one is 10, this one 100. So means that RL will be dominant. So graph will be like this. RL 90. Okay. IC is 10, RL is 100. So there will be 90. Graph will be like this. Yeah, this one is voltage. So the magnitude will be here. Okay, so we can say that when RL is greater than IC, the current will be lagging. Okay, current at bottom. Current here. So we rotate it, current is lagging. V lead I, or I lag V. Okay, we can say that I lag V or V lag I. Okay, case number 2, when RL is greater than IC, for example, this one is voltage, IC, RL. For example, IC is 100, RL is just 10. So the graph will be 90 here. This is the V. So in this case, we can say that using counterclockwise. So I will be leading. I lead voltage, or V lag voltage. Okay. The third case is RL is equal to IC. When RL equal to IC, what happens is, for example, RL 20, IC also 20. So there will be 0. Total will be 0. And we just only have as voltage only. So means that IC minus RL is on the real axis, on this axis. So in this case, we can say this one is same phase. I and V same phase. So no phase different. No leading, no lagging. Same phase or 0 degree. Or sometimes we call it unity. Why? Because we cos 0 equal to 1. So unity. Okay. This one, graph will be like this, case number 3. So when IL is equal to IC, or we can say that imaginary part equal to 0. Okay, imaginary part equal to 0 due to IL equal to IC. This one. I equal to IR plus J IC minus IL. So when IL equal to IC, so this part will become 0. I equal to IR plus J0. So 0 imaginary means that they only have real exist only. Okay, in that for that topic. Okay, now what is resonant? Okay, resonant is in the case where our imaginary part is 0. Okay, we have, okay, that is for admittant. Imaginary part is here. This one is real part. This one is imaginary part J, for J part, imaginary part equal to 0. So we just take omega C minus omega L, omega 1 over omega L equal to 0. Then when we equate it, this one, y equal to 1 over r plus j omega C minus 1 over omega L. So for resonant means that J part is equal to 0. So at resonant, there's no imaginary exists for resonant. At resonant, J equal to 0. So we can say that omega C minus 1 over omega L equal to 0. So omega C equal to 1 over omega L. Omega C omega L equal to 1. So omega square CL equal to 1. Omega equal to 1 over CL square root. Okay, this one is at resonant. This is resonant frequency. Okay, resonant frequency means that imaginary part equal to 0. So the formula for resonant frequency is like this. Okay, any question on this part? No question. So last one is the quality factor. Is quality factor is equal to this formula. Resonant. Okay, quality factor. Quality factor, we just take reactive power divided by active power. Reactive power is the power at the XL or power at the XC. So this formula for Q factor. All right, I think that's all for RLC parallel circuit. So we have an exercise. So any question? So for this exercise, we just using the formula. Using the formula, this one is V peak. This one is omega. This one is theta. So V peak equal to 100. Omega equal to 314. Theta equal to pi over 4. V peak equal to 100. Omega equal to 314. Theta equal to pi over 4, where pi over 4 is 180 divided by 4, 45. 45 theta. So the value of R, L, and C given as 30 microfarad. So we have find total current and also resonant frequency. So current is equal to, okay, so first we find the voltage, admittance, 1 over R plus J omega C. Omega C minus 1 over omega L. Omega C minus 1 over omega L. Okay, plus. Equal to R is equal to 1 over 30 plus J. Omega L is equal to omega 314. L equal to 1.3 milli minus, sorry, not L, C. Well, C is equal to 30 micro. 1 over 314, 1.3 milli. Okay. This one is Y. Unit is mho or Siemens. Mho or Siemens. So next is current. So we know that current is equal to Vy. So we take V. Okay, this one is V peak. So we have to convert to VRMS. To convert to VRMS is V peak divided by square root 2 time Y equal to 100 divided by square root 2 times Y. Y is here. This Y. Put here. Okay, this one is the current of the circuit. And then find the resonant frequency. Omega equal to 1 over LC. Just substitute the value. 1 over C. L is equal to 1.3 milli. C equal to 30 micro. So you will get the resonant frequency. Then quality factor. The quality factor just using formula. This formula for the quality factor. Substitute the value of the given value into that equation, to that formula, we will get quality factor. Okay, I think that's all for the parallel RLC circuit. So it means that we are complete our topic for the RLC and RLC series and RLC parallel circuit. Okay, any question? I think someone raised hand. Okay, so we have two parts. Okay, in the final exam, there will be 2 questions from this topic. So we have one question is RLC, and one question is RLC in series, and this question A RLC series, question B is RLC parallel. So please focus on both these two examples. The question will be similar circuit but different value. RLC, I say both example. We have 2 examples, RLC series and also RLC parallel. So the formula will be given. So any question? So this Friday we will have a quiz. this Friday. Online quiz. Okay, if there's no question, I think we okay. Mosa Hamza. Okay.
Yeah, and the end of this topic, like
Sorry,
from the start to the end of this topic, or from what to what?
sorry again. Can you repeat it?
The quiz can't include this topic, or what from what?
Oh, for the quiz, huh? For the quiz is I think you just study on this slide and the last week's slide, in the same slide, series and circuit, circuit. Okay, for the quiz.
So the quiz is RLC parallel and series, right?
Yes, yes. Okay. Next question. So if there's no question, I think now is 2 minutes to 6. Wow. We straight 2 hour our class. eh, just 1 hour. Okay. Just 1 hour. We can complete it. Tak ada soalan, huh?
No
Okay, I
question,
think
sir.
okay, no question. I think we can stop our class today. So happy New Year. Okay, Muhammad Nur Alif. Yes. What's your question? Oh, tak ada. Okay, it's okay. Okay, thank you very much. See you this Friday for the quiz. Bye.
Thank you, Doktor.
Okay.
Thank you, Doctor. Assalamualaikum.
Salam. Stop recording.